Part 3, Analyzing and Graphing Rational Functions. Use multiplicities to graph the rational function h of x equals x squared minus 2x minus 3 over x squared minus 2x minus 8. We graphed this function in part 2, video part 2. We found the intercepts, we found all of the asymptotes, we graphed the intercepts and asymptotes, and then we knew that the graph will have to cross through the x-axis of both of those intercepts, so we graphed the middle part in between the two vertical asymptotes like that. And then we plotted some additional points to find out what's happening on the right side of the graph and on the left side of the graph. But without plotting additional points, there is another way to know approximately where the graph is in those sections. And we're going to use multiplicities to figure that out. If we look at our asymptote x equals 4, that came from this factor right here, x minus 4, which is to the first power, so it's an odd multiplicity. If the factor where we found the vertical asymptote has an odd multiplicity, then if the graph is going down on one side of that asymptote, it has to be going up on the other side. So the graph here on x equals 4, on the left side of x equals 4, the graph is going down or approaching negative infinity. And because we have an odd multiplicity on that factor, the graph has to be going up or approaching infinity on the other side. If it was an even multiplicity, the graph would be going the same direction on both sides of that asymptote. Let's look at the same thing for the other asymptote, x equals negative 2. That came from this factor, x plus 2, which also has an odd multiplicity. And because at the right side of that asymptote, the graph is going down or approaching negative infinity, on the left side of that asymptote, the graph has to be going up or approaching infinity. Let's graph this function using multiplicities, like we did on the previous example. We have j of x equals x minus 5 squared times x plus 3 over x minus 4 squared times x plus 2. So the domain is everything except for what makes our denominator equal to 0. So x cannot be 4 or negative 2. And in interval notation, that looks like negative infinity to negative 2, union negative 2 to 4, union 4 to infinity. The x-intercepts come from the numerator, so our x-intercepts are 5, 0, and negative 3, 0. And we know the graph is going to cross through the x-axis at negative 3, 0, and touch and turn around at 5, 0, because x minus 5 has an even multiplicity. The y-intercept is when x is 0, so if we set x equal to 0, we get 0 minus 5 squared times 0 plus 3 over 0 minus 4 squared times 0 plus 2, which gives us 75 over 32. So our y-intercept is 0, 75 over 32. Next, let's find the asymptotes. So the vertical asymptotes come from the denominator. We have x equals 4 and x equals negative 2. And our horizontal asymptote ends up being y equals 1 because the numerator and denominator have the same degree. They both have degree 3. And the leading coefficients are 1 over 1. Next, we need to decide if we cross that horizontal asymptote. And to do that, I can take my function and set it equal to 1. So my horizontal asymptote is 1, so I set it equal to 1. If I were to multiply both sides by that denominator, distribute everything out, and solve for x, I would end up with x is approximately 4.5 and negative 9.5. So the graph is going to cross that horizontal asymptote about 4.5 and about negative 9.5. So let's graph. These are all the things that we found. Here's our intercepts and our asymptotes. And then the graph is going to cross that horizontal asymptote at about 4.5 and negative 9.5, which is to the left off of our graph. We're not going to worry about that one right now. So I need to decide what's happening. So on the graph that we can see, the only place we're going to cross that horizontal asymptote is what I just showed you, that red point. And I know that at this point, 5, 0, we need to touch and turn around. So it makes sense that our graph is going to end up something like this. We have to be getting closer to these asymptotes. So when it comes down and we touch this x-axis and turn around, then we still have to start approaching that horizontal asymptote. Then I'm going to look in the middle of the two vertical asymptotes. So this asymptote is x equals 4. So we have an even multiplicity on x minus 4, which means because the graph is going up or approaching infinity on the right side, it has to be going up on the left side. And we know that at some point we're going to come through here and go toward the other asymptote. We can't cross the horizontal asymptote again. The only places it will cross is about 4.5 and negative 9.5, so not in between those two asymptotes. So I know it has to be going back up because it can't go down and cross that horizontal asymptote. Then on the left side, I do have an x-intercept here. We know we're going to cross through. And I also know that asymptote, x minus 2, came from the x plus 2, which has an odd multiplicity. So because the graph is going up or approaching infinity on the right side of that asymptote, it has to be going down on the left side. And then I will connect that with this x-intercept that it crosses through and then approach the asymptote. Let's write an equation for this function. So f of x equals, we know it's a rational function here. Let's look at what we have. We have an x-intercept at 2, so our numerator needs an x minus 2. We're crossing through the x-axis there, so we need an odd multiplicity. I'm just going to start with a multiplicity of 1. Next, let's look at our vertical asymptote. So it looks like we have a vertical asymptote at 4, so we have x minus 4. But that asymptote needs to have an even multiplicity because the graph is going up on both sides of that asymptote. The other vertical asymptote looks like it is at negative 1, so we have an x minus a negative 1 or x plus 1, and that asymptote needs an odd multiplicity, so I'll start with 1 for that one. Next, let's look at the horizontal asymptote. So the horizontal asymptote is at 0, so the numerator must have a smaller degree than the denominator. Right now, when I look, my numerator has degree 1, denominator has degree 3, so that seems to work. If we also look at the y-intercept, if I set all my x's equal to 0, I'd have negative 2 over negative 4 squared times 1, which would be negative 2 over 16, and that looks approximately where my y-intercept goes, so that makes sense for that. And here's our function. Looks like that makes sense with the graph that was given.